Hello and welcome to our lesson on the sine and cosine rules. In this lesson, we aim to deepen our knowledge of triangles by introducing two powerful trigonometric tools, the sine rule and the cosine rule. Additionally, we will learn a new equation for the area of a triangle using these rules. Here's what we'll cover. First, we will introduce the sine rule and how it helps us find unknown sides and angles in non-right-angled triangles. Then we will look at the cosine rule and its application in solving triangle problems where the sine rule cannot be directly used. Finally, we will learn a new equation to calculate the area of a triangle using sine. In our previous lessons, we've established a solid foundation by discussing Pythagoras' theorem, as well as the trigonometric ratios of sine, cos, and tan to find missing sides and angles in right-angled triangles. With this foundation in place, we are now ready to explore the sine and cosine rules. These techniques are especially valuable because they allow us to solve for unknown sides and angles in any triangle, not just right-angled ones. Let's get started. The Sine rule is a crucial tool for solving non-right-angled triangles problems. The rule states that A over sine A equals B over sine B equals C over sine C, where lowercase a, b, and c are the lengths of the sides of the triangle, and uppercase A, B, and C are the angles opposite these sides respectively. The rule can also be rearranged to sine A over A equals sine B over B equals sine C over C. This version of the rule is useful for finding missing angles. Let's work through a case of applying this technique. We're given a triangle ABC with B equals 15 degrees, C equals 56 degrees, and A equals 10 centimeters. We need to find side B. Since we know two of the angles in the triangle, we can use the fact that angles in a triangle sum to 180 degrees to find the value of angle A. Subtract 56 and 15 degrees from 180 degrees to find that angle A equals 109 degrees. Recall the sine rule, which we can use to answer this question. Use the first part of the sine rule A over sine A equals B over sine B, and sub in for the information that we know from our diagram. Therefore, we get 10 over sine 109 equals B over sine 15. Rearrange this to solve for B. We find that B equals 10 sine 15 divided by sine 109. Typing this into a calculator, we find that B is approximately 2.74 centimeters. Now let's turn to the cosine rule. The cosine rule is useful when you know two sides of a triangle and the included angle, or when you know all three sides and want to find an angle. The rule states a squared equals b squared plus c squared minus 2bc cos a, where lowercase a, b, and c are the sides of the triangle and uppercase A is the angle opposite side A. The rule can also be rearranged to cos A equals b squared plus c squared minus a squared divided by 2bc. This is useful for cases where you need to find the missing angle. Let's look at an example of this rule in action. Suppose we have a triangle with sides A equals 5 centimeters, B equals 8 centimeters, and C equals 10 centimeters. Imagine we want to find angle A. Step 1 is to recall the cosine rule. Then substitute in known values as follows. 5 squared equals 8 squared plus 10, squared minus 2 times 8 times 10 cos A. We can then simplify this to 25 equals 164 minus 160 cos A. Finally, rearrange this equation to solve for cos A. We find that cos A is approximately 0.86875. Using the inverse cos function on your calculator, find that A equals inverse cos of 0.86875, which is approximately equal to 29 degrees. The final rule we shall introduce states that the area of a triangle can also be found using the sine of an angle. Area equals half AB sine A, CC. Let's look at this example together. Given a triangle with side A equals 4 centimeters, side B equals 4 centimeters, and angle C equals 60 degrees, find the area. First, substitute the values from the diagram into the area formula. Next, calculate sine 60 to find root 3 over 2. Then sub this back into the formula and simplify to find that the area is approximately 6.93 centimeters squared. Using these rules and formulas, you can effectively solve for unknown sides, angles, and areas in any triangle, enriching your toolkit for tackling a wide variety of geometric problems. In today's lesson, we explored the sine and cosine rules, powerful tools for solving non-right-angled triangles. We began by introducing the sine rule, which states that the ratio of a side length to the sine of its opposite angle is constant within a triangle. This rule allows us to find unknown sides or angles when given sufficient information about a triangle's dimensions. Next, we examined the cosine rule, which relates the lengths of a triangle's sides to the cosine of one of its angles. This rule is particularly useful when we know two sides and the included angle, or all three sides and need to find an angle. Finally, we introduced a new formula for calculating the area of a triangle using the sine of an included angle, enhancing our toolkit for determining areas of non-right-angled triangles. Well done for today, and keep revising these rules.